Good morning, students. Welcome to the discussion of question paper 32 from winter 2013 exam. In today's lesson, we will discuss question number 1 until 5, which will be discussed in 5 separated videos. Let's start from question number 1. A school athlete does a sprint training run. Figure 1.1 shows how her speed varies with time. Explain how the graph in figure 1.1 can be used to determine the distance she runs. Now please remember that from speed-time graph, to calculate the distance, we can calculate the area under the graph. But the graph that we have here does not show any symmetrical shape. So it is impossible for us to calculate the exact number for the distance she runs. Instead of calculating, we better measure the area under the graph to have a better approximation to the distance she runs. So the correct answer for question 1A is the distance can be determined by measuring the area under the graph. Now, let's move on to question B. Determine her maximum acceleration. Show clearly on the graph how you obtain the necessary information. To calculate the acceleration, we have to know the difference in velocity and also the difference in time. To obtain both informations, we have to go back to the graph. The graph will show us also the position for the maximum acceleration. On the graph that we have, the gradient is not constant. The gradient of speed-time graph equals to the acceleration. So we have to find which part of the graph will give us the greatest gradient, which also the maximum acceleration. This part of the graph has the steepest curve. Therefore, we can conclude that the maximum acceleration will be given by this part of the graph. The question asks us to show on the graph clearly how to obtain the necessary information. So, we have to draw a right angle triangle on the graph like that. The right angle triangle gives us two values of points. These 2 points will be used to calculate the gradient of the graph. This one, follow the line here until the x-axis. The value of this is 2.2, 2.4, 2.6, 2.8. The line falls between 2.6 and 2.8. So we can assume that the value of the x-axis is 2.7. The value for the y-axis equals to 6. This point, the value for the x-axis, if we follow this line until the x-axis, it falls between 2 and 2.2. So the value on the x-axis is 2.1. And the value on the y-axis is 4. These 2 points are used to calculate the gradient. So now we have 2 points which values 2.1 with 4 and 2.7 with 6. The acceleration from the speed time graph equals to the rise over run. The rise is 6 minus 4 over the run is 2.7 minus 2.1. These values come from these 2 points. This is equal to 2 per 0.6. Use your calculator to calculate the value. You will get 3.3 meter per second squared. This is the answer for the maximum acceleration. Put that on the space provided, 3.3 meter per second square. Make sure you use the correct unit for the acceleration. Now let's move on to question C. She runs a distance of 62 meters. Calculate her average speed. Average speed can be calculated as distance over time. We have the distance here, 62 meters, but the time we have to look in the graph. What is the time needed to run the distance? From the graph, we know that the time needed is 10 seconds. Now we can calculate the average speed. This is equal to 62 over 10, which equals to 6.2 meter per second. This is the answer. Write down on the provided space 6.2 meter per second. Again, use the correct unit for the answer.